This is our first section in discrete structures, and we're going to start by building up our syntax and building up some of the foundations for what we're going to be doing later on in the course. And in this section, we're going to start off with statements and statement forms. We're going to look at truth tables. And we're also going to start taking a look at arguments and argument forms. We're going to be looking at Boolean algebra. And we're going to start taking a look at some other ideas of being able to write different types of conditional statements. And we're also going to be taking a look at the inverse, the converse, and the contrapositive. So these are all terms and concepts that we're going to be looking at throughout this section. So if you want to kind of take a look at the big ideas that we're going to be looking at, these are the big ideas that we should be ready to look at. So let's start by building up some of our syntax, and let's start by looking at some of the basic definitions. And when we talk about a statement is basically a sentence that's either true or false, but it's not both. In other words, it's not an opinion. It could either be quantitative or qualitative. So it could be numerical or it could be non-numerical. There's simple statements and there's compound statements. As you would imagine, a simple statement has one idea. A compound statement has more than one idea. Right? And usually compound statements are conjoined by an and, an or, a but, or something like that, a logical connector, which we're going to talk about in a moment. Sometimes there's statements that are always true. These are called tautologies. So a tautology is a statement that's always true. And in this course, if we see a capital T, that means we're going to be looking at a tautology. If a statement's always false, that's a contradiction. And a contradiction for us is always going to be denoted by a lowercase c. All right, so if you see these two symbols, make sure you just identify them as a tautology or a contradiction. Now, whenever we want to develop a compound statement, we usually conjoin two simple statements, and we conjoin those with these logical connectors. A logical connector is an and we use an upside down or a V to be able to denote that it is an and we call this a conjunction. Right? So if we conjoin two statements, it's a logical connector of an and. Disjunction is a V. Okay, it's a little bit more spaced out than a V, and that's an or. And if we want to do a negation of a statement, we just use this tilde right here. It's a squiggle, and that's the negation. And then finally, we use an arrow to indicate an if-then. So when we try to make up a statement and logical connectors, that's called a statement form. So a statement form is an expression made up of statements and logical connectors. And in a conditional statement, we have the antecedent, and a conditional statement is an if-then. So whatever the if is the antecedent, and the conclusion is going to be what we end up with. So that's the statement that ends up, or that is the second part of one of those conditional statements. So one of the very first things that we have to do is we have to make sure that we can try to construct statements symbolically. And so let's take a look at a few examples of this. We have this statement, the sky is blue and the grass is green, and we'd like to be able to write that symbolically. So here's how we're going to do that. The first thing we're going to do is we're going to define two variables. Let's call one P, and that's going to be one part of the statement. And this part, or this is expression, or this statement, we have two different parts, or we have two different statements that are simple. So we have the sky is blue, the grass is green, and then we have a conjunction there. All right, so let's define P to be the statement, the sky is blue. And let's define Q to be the statement, the grass is green. And from there, what we can do is we can just go ahead and construct the statement. So we have P, we have Q. So this is our P, this is our Q, and our and, remember, is the upside down V. So the way we would try to denote all of this is by defining P and Q and then using this connector to define P and Q. All right, so we always have to make sure we define all our statements. Another example, we have that Sean is tall or Kathy is Canadian. So once again, we're going to define two statements. So let's call P. Now there's a couple ways we could define this, but we could say, let's do it two different ways. Let's say P is Sean is tall. And let's say Q is Kathy is Canadian. So if we do it that way, we can clearly see that we have, this is our not P, right? Because it's Sean is not tall. Kathy is Canadian, which is Q. And then we have the or. So in this manner, we can define it as not P or Q, all right? Now there is another way to define this. In fact, there's several different ways. So let's say we didn't want to do it that way. Another way we could have done this is we could say define P to be Sean is not tall. Okay, and that's perfectly fine. Then we could clearly see that this is going to be P or Q. All right, so there are two different ways to be able to do this one correctly, but it's probably better to do it the first way, just to keep it as simple as possible. One third example, if I'm rich, then I am not a teacher or I'm a politician. So in this one, it seems that we have three simple statements. I'm rich, I'm not a teacher, I'm a politician. Notice that the if then, we don't include that. All right, so when we go to, if we have a conditional statement, what we're going to do is we're going to start by saying that P is going to be equal to I am rich, not if I am rich. All right, because that's not a statement. I am rich is either true or false. If I am rich is not either true or false. Q, I am a teacher or I am not a teacher. I'm just going to say I am a teacher. And then finally R, I am a politician. And when I go through and define this, here's how I'm going to do this. Now remember, if then is an arrow. Right? So we have an if then, right? We're going to have P, we have not Q, and then we have this or. Right? And so if I wanted to define this, I could define this as P implies not Q, and I'm going to put parentheses on it because that came first, or R. All right. Now, again, not the only way that you could do this, but it's one of the many ways that you could define this symbolically. And every time we do this, we have to make sure that we give the definitions for P, Q, and R. Much like a computer program, if you don't define the variables or if you don't define the variable type, then the program's not going to be correct. Very similar in this aspect. If we don't define P, Q, and R to be these simple statements, then unfortunately, it's not going to be correct. In the next section, we're going to start taking a look at truth values, truth tables, and compound statements.